The overall goal of the following procedure is to isolate and quantify peptides in a complex mixture that act as surrogates for their respective protein. First, large proteins within the mixture are digested to component peptides using an enzyme such as trypsin. Then, the targeted peptide analytes and a spiked stable isotope-labeled internal standard are enriched using antipeptide antibodies immobilized on protein G-coated magnetic particles. Following isolation, the targeted peptides are eluted from the magnetic particles and analyzed by mass spectrometry for quantitation relative to the internal standard.
The main advantages of this technique over existing methods, like traditional immunoassays, is that it is faster and more cost-effective in building large numbers of assays, it has a high success rate, and it is readily multiplexed. Demonstrating the procedure will be Lei Zhao, a technician in the laboratory.
Thaw a 10 microliter plasma aliquot on wet ice. Transfer the sample to a 1000 microliter deep well plate and cover with pierceable film. To denature the proteins, add 20 microliters of fresh 9 molar urea 30 millimolar DTT to each sample and incubate for 30 minutes at 37 degrees Celsius. Add 3 microliters of fresh 500 millimolar iodoacetamide to each sample and incubate for 30 minutes in the dark at room temperature. Now, dilute the urea to 0.6 molar with 100 millimolar tris pH 8 and add 10 microliters of 1 microgram per microliter trypsin stock solution for a 1:50 enzyme to substrate ratio. After incubating the reaction at 37 degrees Celsius overnight, add 3 microliters of neat formic acid to a final concentration of 1%. Continue to add the stable isotope standard or multiple standards if performing a multiplexed assay. Wash the Oasis cartridge plate well with 500 microliters of 0.1% formic acid in 80% acetonitrile, discarding the flow-through. Then equilibrate the cartridge plate by adding 500 microliters of 0.1% formic acid in water and discard the flow-through. Load the digest samples onto the cartridge plate and adjust the vacuum so the flow is very slow. Wash 3 times with 500 microliters of 0.1% formic acid in water and discard the flow-through. Elute the peptides twice with 500 microliters of 0.1% formic acid in 80% acetonitrile. Then lyophilize or speed back the eluate to dryness and reconstitute the dried peptides in 50 microliters of PBS plus 0.03% chaps. Transfer the samples to a standard Kingfisher 96 well plate. Add 1 microgram of antibody and 1.5 microliters of protein G-coated magnetic beads per target. Vortex the beads prior to addition to ensure that the beads are well suspended. Cover the plate with foil and incubate overnight with gentle tumbling. Centrifuge the plate at 400 RPM for 10 seconds to remove any liquid from the foil's surface. Remove the foil cover. Sample manipulation occurs on an automated Kingfisher platform. On the Kingfisher platform, wash the beads twice with 200 microliters of PBS plus 0.03% chaps and once with 200 microliters of a 1:10 dilution of PBS plus 0.03% chaps. Now, elute the peptides with 25 microliters of 5% acetic acid plus 0.03% chaps. Place the elution plate on a magnet and transfer the eluate to a 96 well plate, taking care not to transfer the leftover beads. Cover the plate with a sealing mat. Deliver this plate containing the eluate to the triple quadrupole mass spectrometer for analysis. The MRM method is constructed by obtaining a tandem mass spectrum of the peptide of interest, then choosing and optimizing the best transition fragment ions. Typically, a configuration for MRM analysis uses a C18 trap and analytical columns with 2 mobile phases. Load 10 microliters of the sample and elute by a linear gradient. Integrate peak areas for the light and heavy peptides and calculate the peak area ratio of unlabeled to labeled peptide in each sample. The light and heavy peptides elute at the same time, and multiple transitions can be monitored for each peptide to confirm the identity. The peak area of the endogenous peptide is measured relative to the area of the internal standard to provide a quantitative measure of the target peptide.
After watching this video, you should have a good understanding of how to implement this technique in your laboratory. It can be used to quantify any protein of interest, making it suitable for a broad range of applications in biological research.